Welcome for this VLSI design lecture series. In today's video, let us focus upon a brief history of MOS transistors. Silicon, which is a semiconductor, forms the basic starting material for most of the integrated circuits. Silicon is a group 4 element and it forms covalent bonds with four adjacent atoms, as shown in the figure below. So if you just observe this particular figure, it's very clear that silicon atoms forms covalent bonds with its neighboring atoms. As the valence electrons of it are involved in chemical bonds, a pure silicon is an insulator. But the conductivity of silicon can be increased by introducing small amounts of impurities called as dopants into the silicon lattice. A dopant from a group 5 element in the periodic table, such as arsenic, which has 5 valence electrons, it can replace a silicon atom in the lattice and still bonds with 4 neighboring atoms. But the 5th electron will be left free, or it will be loosely bounded, which is as shown in the figure. If we observe over here, arsenic forms covalent bond with 4 of its neighboring silicon atoms, but one of its electron is left free, or it is loosely bounded. So this kind of semiconductors where electrons are majority charge carriers are called as N-type semiconductors. The free electron can carry current, and hence this kind of semiconductor is called as N-type semiconductor. Similarly, there is one more variation of semiconductor called as P-type semiconductor. A group 3 impurity, such as boron, will have just 3 valence electrons. So when it has just 3 valence electrons, the boron forms covalent bonds with its 3 neighboring silicon atoms. But it cannot form covalent bonds with the other neighboring silicon atom, which is a 4th neighboring silicon atom, and a hole is created. Because holes are called as positive charges, this kind of semiconductor is called as P-type semiconductor. So it is perfectly shown in this particular diagram. A positive hole is created. Now let us discuss about metal oxide semiconductor field effect transistors. So normally MOS stands for metal oxide semiconductor, which is created by superimposing several layers of conducting and insulating materials to form sandwich-like structure. In CMOS technology, we have two kinds of transistors: N-type transistor, which is called as NMOS transistor, and P-type transistor, which is also known as PMOS transistors. Transistor operation is controlled by electric fields. So generally we call it as metal oxide semiconductor field effect transistors, or simply we call it as FETs. So let us see a cross-sectional view as well as symbolic representation of these transistors. So if we just observe the diagram which is shown here, we can see a NMOS transistor, which is highlighted here, and a PMOS transistor, which is present at the right side of your screen. This is the NMOS transistor, and this is a PMOS transistor. So both these NMOS transistor and PMOS transistor consist of 3 terminals: gate terminal, source terminal, and drain terminal. So there are 3 terminals with respect to both NMOS transistor as well as PMOS transistor. And we have 3 types of materials which we are using: polysilicon, silicon dioxide, which is an oxide layer, and finally a substrate. So let us focus upon N-channel MOSFET separately and P-channel MOSFET separately. Let us first discuss about NMOS transistor. So this NMOS transistor is built with a p-type body. It is built with a p-type substrate or a p-type body and has regions of n-type semiconductors, which is adjacent to the gate, and it is called as source terminal and drain terminal. This NMOS transistor, initially, if we observe, it has a p-type substrate where holes are majority charge carriers. So entirely in this p-type substrate, holes will be the majority charge carriers. Somewhere here and there will also be electrons, which are the minority charge carriers. Initially, when this particular gate voltage is 0, initially let us assume that the gate voltage is 0. So when the gate voltage is 0, the transistor is said to be turned off. The reason behind it is very simple. In this n plus region, electrons are the majority charge carriers. And similarly, in the n plus region, which I'm highlighting over here, even here, electrons are the majority charge carriers. Whereas in between these two n plus regions, we have a p substrate where holes are the majority charge carriers. So whenever there is no gate voltage applied, there is no formation of channel. Means there is no continuity here. If we observe, there is no continuity for the flow of current from source to drain terminal, as the source terminal has no number of electrons, this drain terminal has electrons, whereas in between these electrons we have holes. In order to make sure that the transistor turns on and electricity passes through it, some amount of positive gate voltage is applied. Some amount of positive gate voltage is applied. So when positive gate voltage is applied, according to the law of charges, like charges will repel and unlike charges will attract. So because of that, because of the positive gate voltage, electrons are minority charge carriers in p substrate, whereas because it gets attracted to the positive, it comes and settles at the just below the gate, whereas all the positive charge carriers which were present will be pushed away because like charges will repel and unlike charges will attract. So because of this, if we observe, there is a channel of electrons which is connecting source and the drain terminal. So because there is a channel of electrons which is connecting the source and drain terminal, there forms a path for the flow of electricity. And this state of transistor is termed as on state. Similarly, let us consider the working of PMOS transistor. Again, as told previously, even this PMOS transistor consists of 3 terminals: source terminal, drain terminal, as well as the gate terminal. Initially, let us assume that this gate terminal is made positive, or positive gate voltage is supplied to the gate terminal of the PMOS transistor. So when positive voltage is applied to the gate terminal of PMOS transistors, in this n-type bulk, electrons are majority charge carriers. So electrons will be settled just beneath the gate layer. Whereas with respect to this n-type bulk, electrons are the majority charge carriers. Whereas here and there, we will be seeing some positive charge carriers as well. Now let us assume that the gate is made positive. As I told you previously, it is made positive. So when the gate is made positive, because electrons get settled beneath the gate layer, there will be no connectivity between the source and the drain, because This source is connected to P plus region where holes are the majority charge carriers, both with respect to source as well as drain. Holes are majority charge carriers. Whereas in between these holes, we have channel of electrons, and there is no connectivity between the source and drain terminal. There is no connectivity between source and the drain. This state of transistor is termed as off state. It is termed as off state. Now let us consider that the gate input of this PMOS transistor is supplied with the negative voltage. Is supplied with the negative voltage. So when negative gate voltage is applied to the gate terminal of a PMOS transistor, because of the law of charges, like charges will repel, whereas unlike charges will attract. So because negative gate voltage is applied, positive holes gets settled just beneath the gate layer. And with respect to this P-type semiconductor, holes are majority charge carriers. And similarly here we have one more P region, even there holes are majority charge carriers. If we observe, there is a connectivity which is established, or there is a path which is established between source and the drain terminal. So because of the formation of this channel of holes, there is a connection between the source and the drain terminal. This state of transistor, this state of PMOS transistor is termed as on state. So in digital level abstraction, NMOS transistor turns on when gate input given to it is logic 1. And NMOS transistor turns off when its gate input is equal to 0. Similarly, PMOS transistor turns on when its gate input is 0. And PMOS transistor turns off when its gate input is made as 1. I repeat once more. NMOS transistor turns on when its gate input is equal to 1. Whereas NMOS transistor turns off when its gate input is 0. PMOS transistor turns on when its gate input is 0, and PMOS transistor turns off when its gate input is 1. I hope you have understood the concepts which we have discussed in this video session. See you all in the next video.